Okay, we've got a presentation here on OPNAV 5119, your Safety and Occupational Health Afloat, Chapter B2, Heat Stress. So let's start by defining what heat stress is. We're going to say heat stress is any combination of air temperature, thermal radiation, humidity, airflow, workload, and health conditions that may stress the body as it attempts to regulate body temperature. So we've just got the ambient temperature in the room, any thermal radiation, anything generating heat, any humidity, right, the airflow or ventilation. We got to consider what type of work we're doing in the space, and then the health condition of the individual. This all contributes to what we define as heat stress. To obtain accurate and reliable data on heat stress conditions, ships are going to conduct heat stress surveys, and they're going to record dry bulb, wet bulb, and globe temperatures. And with these three temperatures, we get an index that helps us accurately see what the heat stress condition is like. The Navy is going to use either a wet bulb globe temperature, a WBGT meter, or the automated heat stress system to measure the above temperature. So WBGT meter is this meter you see right here in the picture that's portable, and the automated heat stress system is something that would be built into a ship. All right, the WBGT index and the physical exertion levels are used to determine how long an individual may be exposed safely to heat stress conditions. So we've got to get this index, right, to get an idea of what the heat stress conditions are like. And then we've also got to consider what kind of work we're going to be doing in that space, okay? So in order to determine how safely somebody could be in this, we've also got to consider what are they doing, right? This information is presented in a columnar format, right, and the reference and this reference by means of a physiological heat exposure limits chart, or a PHEL chart. All right, so PHEL stands for physiological heat exposure limits. What we do with this, and we'll see it on the next couple of pages here, but we take into consideration what the heat conditions are like using that WBGT meter, right? Looking at the dry bulb temperature, the wet bulb temperature, and the global temperature, and then we also look at what kind of work is being done, and we're going to look at the PHEL chart, right? The physiological heat exposure limits chart, and that's going to help us determine how long somebody can safely work in a space. All right, and then we say heat acclimatization occurs gradually, and it usually requires 3 weeks or more. Okay, so to acclimatize to heat conditions, it takes at least 3 weeks. Physiological heat exposure level determinations, or PHEL determination. The WBGT index is going to provide a measure of environmental conditions. Like we said in the previous slide, we're going to take the wet bulb to get the humidity, dry bulb for the ambient temperature, and our global temperature for the radiant heat, and we get an index. In order to determine the permissible heat exposure of these conditions, the amount of work of a particular job must be known. So not only do we need to take that WBGT index, but we've got to know what type of work, how hard the work being done in that space is. The most strenuous the job, the shorter the allowable exposure time. The Navy has developed 6 PHEL curves, each applying to different work rate ranging from light work to heavy work. So when we're talking about PHEL 1, right, PHEL curve 1, that's very, very light work. And then on the other end of the spectrum, we've got PHEL 6, that would be our heavy work. So towards the end of the reference and the end of the chapter, you'll see this PHEL chart that shows how your PHEL curves all work. So if you see these curves on the line, they're numbered, right? Just like we said, we've got PHEL levels 1, 2, 3, 4, 5, and 6. 1 being the light work, right? And then 6 being the very, very heavy work down here. And if you look at this chart, on the y-axis we see the WBGT index, and then on our x-axis we see the exposure times, how long the person's in the space. And the way this is used is you go get your reading in a space, right? You take your WBGT meter and you go get your reading in your space, and we'll say that we get a reading of 85. If you got a reading at 85 degrees, and now you got to know, well, what kind of work is being done in that space? And if it's very light work and it's determined to be a PHEL level 1, the way we would use this chart is we take this 85 degrees and we just come across. We'd come across and see if that one curve crosses it ever, and it doesn't. Right? We see the one curve kind of just keeps going on and on, so we can work greater than 8 hours in this space if it's a PHEL level 1. Now, if it were a PHEL level 2, I'll change the color right here to, let's go with the purple. If I'm a PHEL level 2, right, so a little bit more work, right, we determine that the work is actually PHEL level 2, and I still get that 85 degrees, and I come across, right, coming across, and then I do see that this 2 curve, this 2 curve actually is going to cross that line right before we get to 7 hours here. So there is a limited amount of time that I could be in a space if I'm working FEL level 2. If the job calls for 8 hours, you can see on this chart that we can't work in there for 8 hours. So when it comes to the curve selection, it's based on healthy personnel who have adequate rest and recovery from previous heat exposures. If a heat injury does occur, we're going to go ahead and make the stay time for all other personnel in the space. It's going to be reduced by recalculating the stay times using the next numerically higher FEL curve. So if we've got a heat injury, we've got a heat injury in a space, and that space was previously a FEL 1, we're going to make it a FEL 2. Well, because it's a FEL 2, we might have to recalculate our stay time based off what the WBGT index is. Okay, so heat injury occurs, we automatically go to the next numerically higher FEL level. The WBGT index is rounded to the next higher whole number. So I'm going to pull up the chart on the next slide here, and you're going to see if we get a reading of 84.1, we're going to round it up. Okay, we're going to always round it up, and we're always going to get a whole number, and you'll see why on the chart. Right, and before we go to the chart, just kind of notice the reason we need the chart is, I mean, this is going from 80 to 85. It might be hard to see precisely where these cross the line, and then for our time as well, it's, we got whole numbers on here. Okay, so this is what your chart looks like. It's the same thing, but it's going to give you a more precise number. So you could see the chart. We've got FEL level 1, light work, FEL level 6, the heaviest of the work. And if we've got a WBGT index of 80 degrees, FEL level 1, we could stay greater than 8 hours, FEL 2, greater than 8 hours, 3, greater than 8 hours. Once we hit FEL 4, that's going to be 8 hours on the nose. 5, we're under 8 hours, right? 635. And then FEL level 6, we're doing really heavy work in it with the WBGT index of 80. That stay time for that space would be 4 hours and 30 minutes. And then you can see, right, as the WBGT index goes up, the stay times are going to drop. Heat stress elements. Right, so heat stress elements are going to include monitoring and surveying of heat stress conditions, establishing safe work schedules in heat stress environments, investigating and reporting personnel heat injuries, training, and then record keeping. Monitoring and surveying of heat stress conditions, right? We monitor by recording dry bulb temperatures, okay? So we use a dry bulb thermometer, your classic thermometer with alcohol and glass, and we use these in specified watch or workstations. Surveys, when it comes to surveying, that's when we're using the WBGT meters, or we're using the automated heat stress system built into the ship to measure both that dry bulb, that wet bulb, and that global temperature, and we're going to compute a WBGT index. Let's talk about dry bulb thermometers. So we're going to say a hanging dry bulb thermometer shall be permanently mounted at watch or workstations through the ship where heat stress conditions may exist. They should also be mounted in non-air conditioned spaces not normally manned, in which personnel may have to periodically work or conduct maintenance. They're going to be mounted in a position that most accurately represents the temperature where the workers and watch standards spend the majority of their time. They must be hung at least 2 feet from any supply ventilation or terminal opening. So we don't want these things standing right in front of an air conditioning vent, because it's not going to accurately reflect the temperature within the space. So it's got to be at least 2 feet from any supply ventilation or terminal opening. Shall be hung with a non-heat conducting material such as plastic ties or string, right? We don't want anything metal that can, conduct heat from another source. If the difference between the hanging dry bulb and the dry bulb temperature measured when we get a WBGT meter reading during a survey is 5 degrees or greater, then that dry bulb is not representative of the temperature in the workstation, okay? So you got your hanging dry bulb within the space, and then the surveyor comes in to do a WBGT reading, and on their meter, they got a difference of 5 or more on their WBGT meter. When it comes to that dry bulb, we're going to say that dry bulb thermometer in the space is probably not very good. It's not representing the true temperature in that workstation. And then ships are going to install dry bulb thermometers in any main machinery spaces, any auxiliary machine spaces, any emergency diesel spaces, any laundry dry cleaning spaces, any sculleries, any galleys, any bake shops, and any steam catapult spaces. The ship shall record dry bulb thermometer readings when the ship is underway or when potential heat stress conditions exist while in port. Assigned personnel are going to monitor compartments as follows. Every 4 hours for manned spaces if the dry bulb temperatures do not exceed 85 degrees. Every hour for manned spaces if dry bulb temperatures exceed 85 degrees. And every hour at temporary installations where the dry bulb exceeds 85 degrees during repair or maintenance operations. Okay? Every 4 hours in manned spaces if it's not over 85 degrees. Every hour when it exceeds 85 degrees. And then every hour at temporary installations where the dry bulb thermometer exceeds 85 degrees during repair or maintenance operations. Recording dry bulb temperatures. So hanging dry bulb temperatures shall be recorded on a paper log form and reviewed by the space supervisor. They're going to be circled in red if the dry bulb temperature is greater than 100 degrees for watch and work length 4 hours or less. All right, so if it's a space we're in 4 hours or less and it's greater than 100 degrees, we're going to circle it in red. It's going to be circled in red if the dry bulb temperature is greater than 90 degrees for watch work length greater than 4 hours. So if it's greater than 4 hours, we're in the space, right? The dry bulb temperature is going to be circled if it's greater than 90 degrees. And then if the dry bulb is greater than 85 degrees in the scullery, we're going to go ahead and circle it in red as well. All right, the watch supervisor is then going to direct that a heat stress survey be conducted and enforce the resulting stay times. So if we've got those temperatures greater than 100 degrees and somewhere we're working less than 4 hours, greater than 90 degrees, somewhere we're working greater than 4 hours, or greater than 85 degrees in the scullery, the watch supervisor is going to make sure that a heat stress survey is conducted. And then when we take that survey, you know, we're going to look at the FEL chart and see if there's new stay times. And if that's the case, then that watch supervisor is going to make sure that those new stay times are going to be enforced. Moving on to the heat stress survey using a WBGT meter. The surveyor uses a WBGT index along with the individual's physical exertion level to determine the permissible heat exposure limits, referred to as the physiological heat exposure limits or the FEL stay times like we discussed before. Measurement techniques. The surveyor should position the meter where the work and watch standards normally stand or where the intended work is to be performed. Right? We're trying to get an accurate representation of the heat that personnel are exposed to, so we'll put the meter where they're going to be working. The heat stress surveyor shall conduct the first WBGT measurement in the workspace after the meter has been in the space for 5 minutes. We got to let that thing sit in there, that meter sit in there for at least 5 minutes before we get the first recording. As the meter is moved from one site to another, the meter should be at each site for 3 minutes to allow for stabilization of the first reading. All right, so 5 minutes initially when we start this thing up, and then once we move it, you know, to different sites, we got to wait for 3 minutes. Measuring techniques. The surveyor shall record readings to the nearest 0.1 degree on the heat stress survey sheet. The surveyor shall use a WBGT index reading to determine the FEL stay time. Right, the surveyor shall record the FEL curve used and the corresponding exposure time all on the survey sheet. The surveyor shall note any stay times for manned, watched, or workstations that, under routine conditions, are less than the watch or work periods, and circle these in red. So when they take the WBGT index and they take the FEL curve and they see that, hey, you know what, this is going to be less time than the watch usually is, like it's a 4-hour watch, but according to this to the FEL chart, you can only stay in here for 3. We're going to circle that in red. Right, and the surveyor is going to notify space supervisors and the responsible department head of any reduced stay times, and the department head shall promptly notify the CO of the conditions and actions being taken to protect personnel. So when it comes to making sure we're getting accurate WBGT readings, the heat stress surveyor, they're going to check, and there's a couple things I should check out in that index. The wet bulb should be less than the dry bulb. The global temperature should be greater than or equal to the dry bulb, and then the wet bulb should be less than the WBGT index, and the WBGT index should be less than the global temperature. Once verified, the stress surveyor will manually calculate the highest WBGT index obtained using the following formula. Right, so the WBGT should equal 0.1 times the dry bulb plus 0.7 times the wet bulb plus 0.2 times the global temperature. Okay, so you've got this manual calculation, right, that you want to check your index reading, and when you do this manual calculation, what you should find, and this is probably what we need to take out of all of this really, is that the calculated WBGT shall be within 0 degrees Fahrenheit of the meter. So what we should be able to do is individually take the dry bulb, the wet bulb, and the global temperature, because the meter is going to give us an index. So and we can also look at all those individual readings. We plug them into that formula, and that formula, when we manually calculate it, it needs to be within within 0.2 degrees Fahrenheit of what the actual meter got. All right, so and then manual calculation, that's not required if we've got an automated heat stress system. This is only required if we're using the WBGT meters, the portable meters, right? The hanging dry bulb, like we said before, is going to be recorded on the heat stress survey sheet as well. And if the difference between the hanging dry bulb thermometer and the dry bulb temperature measured with your WBGT meter is 5 degrees or greater, then we're saying that dry bulb thermometer does not represent the temperature of the workstation. Right, and then following the department head's review, all heat stress survey sheets shall be delivered to the MDR, the medical department representative, and the medical department representative is going to retain all heat stress survey sheets for 1 year. So this is a little bit different. Most of the things we are used to holding on to is 2 years, but when it comes to heat stress surveys, for whatever reason, it's only 1 year. So determining when we actually have to do a heat stress survey, when we got to take the WBGT meter out and conduct a survey. All right, so man spaces that are FEL level 1 through 3, the lighter end of the spectrum when it comes to work, okay? So we're going to do a survey with the WBGT meter and a FEL level 1 through 3 if we notice that the dry bulb temperature is greater than 100 degrees in a space that we're working less than 4 hours. We're going to do it in a FEL level 1 through 3 if the dry bulb temperature is greater than 90 degrees and somewhere that we're working longer than 4 hours. And then with the heavier work, FEL 4 through 6, we're going to do a survey with the WBGT meter in any place where the dry bulb temperature is greater than 85 degrees. We're also going to do we're going to do surveys in any space where heat injuries occurred. So remember, when a heat injury occurs, we got to do a survey, and then before, like we talked about, we've got to knock it up a FEL level. So if a heat injury occurs in a space that we said was a FEL level 3, that the work we're doing is only a level 3, we have to bring it up to a 4, and we also have to do a new survey with the WBGT meter. Prior to conducting any engineer casualty control drills, if the drill is greater than 3 hours or if it's already in a reduced stay time. If the CO wants us to do one, right, in any space where the CO determines that the heat stress situation may occur, we're going to do one. And then when we have follow-on surveys, we've done one and now we've got to conduct follow-on surveys, that's when we'll pull out the WBGT meter and do a heat survey. Right, so recovery time. Supervisors are going to direct personnel standing watch or working in spaces in reduced stay times to leave the heat stress environment prior to expiration of the FEL stay time. So if it's been determined, right, this is a space where we usually work 4 hours, but because of the heat stress conditions, we can only stay in there for an hour. The supervisors are responsible for making sure that their people don't stay beyond an hour and that they get into a different environment, okay? So these personnel are going to move to a cool, dry area conducive to rapid physiological recovery, an area that has a dry bulb temperature of 80 degrees or less. The length of recovery time shall be equal to twice the exposure time or 4 hours, whichever is less. So if the exposure time, like I said, was 1 hour, then they get twice that. They would get 2 hours recovery time, okay? Or 4 hours, whichever is less. Well, in this case, 2 hours is less than 4, so they would get 2 hours. So your recovery time, twice your exposure time, or 4 hours, whichever is less. And then supervisors are going to direct personnel experiencing heat stress symptoms to report immediately to the medical department representative so they can get evaluated. Recommendations for working in heat stress environments. So drink more water than satisfies thirst, but no more than 1.5 liters. We're not trying to cause hyponatremia. Eat 3 well-balanced meals a day. Wear clean clothing composed of at least 35% cotton. Do not take salt tablets. Limit your intake of caffeinated drinks. And the medical department is going to make sure that any heat-related injuries or illnesses are entered into what's called the web-enabled safety system. So any heat stroke or heat exhaustion, it's got to be entered into the web-enabled safety system, and that's the responsibility of the medical department representative. Training. Right, all hands are going to receive heat stress training upon reporting aboard, right? This is an all hands requirement. It can be conducted by showing the video, play it cool, heat stress prevention afloat. Training's got to include heat stress health hazards, symptoms of excessive heat stress exposure, heat stress first aid, heat stress monitoring, causes of heat stress conditions, right? Heat stress surveyors, right? If you're somebody that's going to be using the WBGT meter, right? So your heat stress surveyors, they shall be trained and qualified using the Heat Stress Survey Watch Station 303 within 12 weeks of assignment. Moving on to responsibilities, and we'll start with our commanding officer. So they got to establish and enforce an effective heat stress policy that ensures that personnel heat exposure is limited. They got to review an initial daily heat stress surveys that result in reduced stay times. So if we do a survey on a space and we can't stay in there as long as we normally would, that's got to go up to the CO, and the CO is going to review it, and they're going to initial that survey. They're going to conduct an inquiry into circumstances surrounding heat stress injuries that resulted in unconsciousness. So if somebody has a pretty significant heat stroke, the CO is going to do an inquiry and see what's going on there. They got to report to the ISIC those material deficiencies beyond the ship's force capability to correct, which contribute to heat stress conditions. For ships without an automated heat stress system installed, they got to ensure at least 2 portable, calibrated, and operable WBGT meters are available on board. So if we don't have the automated heat stress system built into the ship, we got to make sure that we've got at least 2 WBGT meters. And then if an automated heat stress system is installed, they got to maintain at least 1 portable and calibrated WBGT meter. Okay, so 2 meters if we don't have an automated heat stress system, 1 meter if we do. Medical department representative. Your MDR is going to review all engineering and non-engineering heat stress surveys to determine obvious inaccuracies, reduce fail stay times, and the personal protective action being taken. They're going to submit heat stress surveys that resulted in reduced stay times to the CO for daily review. They're going to provide training to divisions on heat stress, health hazards, symptoms, prevention, and first aid procedures upon request. And they are going to prepare reports of heat stress related cases. Your engineering officer or your reactor officer, they got to ensure that dry bulb thermometers are installed and temperatures are monitored and recorded. They got to assign and qualify engineering department personnel to perform heat stress surveys in engineering spaces. They got to review heat stress surveys to ensure stay times for engineering personnel are being properly determined and exposure is being limited. And if maintenance or repair is required, they're going to record all heat stress related deficiencies on the current ship's maintenance project, the CSMP. All right, so moving on to a little bit of review here. What are the 3 temperature readings needed to obtain accurate and reliable data on heat stress conditions? 3 temperature readings we need. We need a dry bulb temperature, wet bulb, and our global temperature. What does the acronym PHEL stand for? What does the acronym PHEL stand for? That stands for Physiological Heat Exposure Limits. How many WBGT meters must be on board a ship that is without an automated heat stress system? How many WBGT meters do we need on a ship without an automated heat stress system? We need 2. How many WBGT meters must be on board a ship with an automated heat stress system? Well, if we've got an automated heat stress system, we only need 1. At least how many feet must dry bulb thermometers be hung from ventilation openings? How many feet must dry bulb thermometers be hung from ventilation openings? They got to be at least 2 feet away, right? They got to be 2 feet away. We want them to represent and have an accurate representation of the temperature in the workspace, and we got to make sure we're hanging them using a non-conductive material like string or zip ties or something like that. At what temperature do dry bulb thermometers need to be monitored every hour? At what temperature do dry bulb thermometers need to be monitored every hour? When we're above 85 degrees. How long must a WBGT meter be in a workspace prior to conducting the first measurement? How long must a WBGT meter be in the workspace prior to conducting the first measurement? It's got to be in there 5 minutes. 5 minutes before we get that first measurement. After the first reading, right, with the WBGT meter, if it is moved, how long must the surveyor wait before conducting a measurement? We've already got the first reading. We've moved it now. How long do we got to wait? We got to wait 3 minutes. How many FEL curves are there? How many FEL curves are there? We say there are 6. A difference of how many degrees between the hanging dry bulb and the dry bulb reading from your WBGT meter indicates that the dry bulb does not represent the temperature of the workspace. A difference between the hanging dry bulb and the dry bulb from the WBGT meter, 5 or greater, right? 5 degrees or more means that our hanging dry bulb doesn't represent the temperature of the workspace. In what database must the medical department representative record heat injuries? In what database must the medical department representative record heat injuries? Well, they got to record heat injuries in your web-enabled safety system. Within how many weeks of being assigned must a heat surveyor complete training? Within how many weeks of being assigned must a heat surveyor complete training? They got 12 weeks to get that done. 12 weeks. What is the recovery time for personnel who are working in spaces with reduced stay times? What is our recovery time if you're working in a space with a reduced stay time? Well, it's going to be twice the exposure time or 4 hours, whichever is less. How long must a medical department representative maintain heat stress survey sheets? For how long must the medical department representative maintain heat stress survey sheets? They got to do that for 1 year. A little bit different than most of our record keeping. If you had an index of 84.1 from your WBGT meter, what index would you use when determining the stay time when you're using the FEL table? So you get a reading of 84.1. When you go to look at the table, what index are you going to use? You're going to use 85, right? Whenever we have a decimal, we just round up, right? Because the table is just in whole numbers, and there's no decimals in the table, so we always just round up. So 84.1 would be 85 on the table. Okay, this concludes this presentation on OPNAV 5100.19 Echo B2, your heat stress. As always, I hope this helps, and keep studying.